All right, welcome back, guys. In this video, we're going to talk about inequalities and interval notation, and how do we represent certain set of numbers that has infinitely many numbers inside of it as a short notation where we use quite often in algebra, and that notation is called interval notation. And then I'll briefly review set builder notation as well. So let's start out by looking at the first two inequalities here. So we have minus 3 less than x. So if you see any inequalities and there's a variable x, chances are the x are just an arbitrary real numbers, can be anything. So to interpret this, we say that this means, all possible, all the real numbers. And the real numbers are denoted as x, right? All the real numbers x that is greater than, strictly greater than minus 3, right? So if we want to list a few, we're looking at maybe minus 1, 0, 7, 1, negative 2.999, right? So you get the idea. All these possibilities here, right? Whereas this one here, x is greater than equal to 3. So this means all the real numbers, greater than or equal to 3, meaning 3 is part of the set. So this is both this part here, we call these inequality forms. So inequality form, right? So this is called listing form here. So if we list out all the possible numbers, it's called listing form. But with this type of set of numbers, it's impossible to list all those numbers out. So we're gonna capture these sets. Usually we capture through a drawing or a picture or a number line. So we said, all right, so if I draw the solution set or the set of all the numbers greater than negative 3 using number line, here's my 0 and here is my negative 3. And what we do is we're gonna draw a open circle around negative 3, meaning we don't include 3, negative 3, and we shade everything to the right of negative 3 to indicate that those are the numbers greater than or equal to, strictly greater than negative 3. So this here means all the x greater than negative 3, right? So that's using graphing to show the set of those numbers. Similarly, we can do the same thing for the other set. We want to draw all the numbers that are greater than 3. So here's my 3. All right. So in this case, we want to do a closed circle around the 3 to indicate that it is including the 3. And then is everything to the right of that 3. Okay. All right. So this is all the x greater than or equal to 3. All right. So what is interval notation? Where does it come from? So it turns out that we can capture these two sets instead of drawing it, instead of writing inequality. We can actually use another notation that has the same meaning. Okay, so in this case here, if I want to describe using interval notation, okay, if I want to describe all the numbers that is to the right of 3, that means greater than 3. I say, okay, my left number, my left endpoint is going to be 3, and my right endpoint, there's no endpoint for the right endpoint because it just keep increasing to positive infinity. So I'm going to have that as positive infinity. And the smallest number for this set is 3, and it can be equal to 3. So we use a bracket to include the endpoints. However, we don't use bracket around infinity because infinity is just an idea. So we cannot include infinity, so we use parentheses. Okay, so for that set, and the other set is all the numbers greater than negative 3. Since negative 3 is not part of the set, therefore we have an open circle. So we start with negative 3, and then we use parentheses, and then we do positive infinity because this is containing all the numbers to up to positive infinity. So that's how we capture those two sets using the interval notation. Another thing in this section is that given an inequality, it may be as simple as this or as complicated as this, and we want to simplify that inequality to a form that is in this, something as simple as this, where we can draw the solution, where we can capture solution or describe the solution using interval notation or graphing. Okay, so let's look at the first example here. It said, is 3 a solution to this inequality? To show this, to show a number is a solution to inequality, it means that, does 3 satisfy the inequality? That's what the question is asking. Well, to do that, we just check. We plug in 3 for x. We say, all right, well, I have 1 minus 2 times 3 minus 5. Is that greater than or equal to 8 times 3 plus 7? So this is how we check or answer if we happen to solve an inequality. Okay, so we have 1 minus 2 times negative 2. Is that greater than or equal to 24 plus 7? In this case here we have 31. And then in this case here we have 5. So in this case it's no, it's not. So 3 is not a solution because this right here is a false statement, right? So that's how you check if a number is a solution to inequality. Okay. Moving on to the next example. This is asking to graph the inequality, write each inequality using interval notation and then set builder notation as well. So to graph the first one, this one's saying that I want to graph all the number that is less than -1. So here's my 0, here's my -1. So if I want to graph all the number is less than -1, then I'm going to have an open circle here, and then all the number less than -1 is to the left of -1. Okay, so that's my graph. Okay, and the interval notation is going to be, okay, well, when I write my interval notation, the left number is always going to be less than the right number. So since our highest number can be up to -1 but not include -1, so we use parentheses, and then the smallest number can be as small as -infinity, so we write -infinity to the left. So that's interval notation. Now if I want to describe this using set builder notation, it's pretty simple. We just said, all right, this set here is all the x. Vertical slash means such that, so this means such that. Right, that's what the vertical slash means. So we say this set here is all the x such that, and then what follow the such that is the condition for the numbers in this set. So the condition is all the x less than -1. So there it is. So that's set builder notation. So this is set builder, and this is interval notation. All right, in the next example, we have a set that is go from 3 to 15. It is include both of those endpoints. So here's 0. All right, so I'm gonna say here's my 3 and here's my 15, and I wanna show all the possible numbers between 3 and 15. So I'm gonna do a closed circle. So that's my graph. And then I'm just going to say, okay, my interval notation is from 3 to 15, brackets for both those endpoints, because we include both those endpoints in the set, these numbers. And then for set builder, we can say all the x such that x is between 3 and 15. All right. In the next example, we're going to start with the interval notation, and we're going to graph the interval notation using number line. Okay. So for the first one, if I want to graph all the numbers, if I want to show you all the numbers from -4 to 1, here's my -4, here's my 1. Notice that we don't include the -4, so we can use parentheses if we want to, and then we can use bracket here. Instead of open circle and closed circle, we can use parentheses and bracket to indicate that. Okay. All right. And then if we want to write this using inequality notation, we can say, well, if this is x, then my x's go from -4 to 1, including 1. Okay. All right. I'll let you guys try B and D on your own here. This is really good practice, kind of get familiar with interval notation. Here, question 3 or example 3, we're gonna solve some linear inequality, and I'll walk you through this pretty fast here so it's not as boring. So first we solve for inequality, we write the answer or the solution using set B notation and interval notation and graph the solution. I'll do the first one here. So to solve for x, we want to make this as simplified as possible. So I wanna subtract 3x on the other side, so that gave me negative 2x plus 3 less than negative 7. And then I can subtract 3 on the other side, so that gave me negative 10 on the other side. Then I'm going to go ahead and divide by a negative 2. With inequality, when you divide by a negative, the inequality switch direction, okay? And that has to do with the fact that if your solution were to be all positive number, and you time that set of positive number by a negative, you know, all those positive numbers are going to be negative, so it's going to be on the other side of the number line. So same thing here. If the inequality is less than, and if you divide by negative or times by negative, it's going to switch the values of all those solutions. So the inequality needs to be switched. So we're just going to graph this here. All the x greater than 5. So here's my 0. 1, 2, 3, 4, 5. Here's my 5. And I'm going to go ahead and use parentheses here. So all the numbers greater than 5, right? And then my interval notation, I'm going to start at 5, and I'm going to go to positive infinity, parenthesis for both of them. Okay. Set B notation is all the x such that x is greater than 5. All right, pretty simple. I'm going to give you a hint for this part B. I'm not going to do it though. So to simplify this here, you want to times this by the LCD, which is 15 for both sides, to allow us to cancel out the fraction. Okay, so I'm going to times this by 15. Okay, and then times by 15. So by doing that, you get 4x greater than 24, and then you can solve for x after that. Okay. C, I believe this one is a unique case. So if I distribute the negative 2, I get negative 2 plus 2x greater than 7x plus 4. Maybe it's not a unique case. We have minus 2 plus 4x greater than 7x plus 4. Subtract the 4 on the left, so that gives us negative 6 plus 4x greater than 7x. And minus 4x the other side, so we're going to get 3x there, and then divide by 3. So we're going to get negative 2 greater than x. Now we want to graph all the number that is less than negative 2. So here's negative 2. So all the number less than negative 2 is going to be to the left of that. So here is my graph. And then the interval notation is going to be from negative infinity up to negative 2, parentheses for those endpoints. All right. Exercise 4 is an example of inequality. This problem is kind of tricky. You do have to read a little more to extract the correct information. So just saying that an unconditional acceptance into a graduate program at a university will be given to students whose GMAT score plus 400 times the graduate grade point average is at least 1500. Robin's GMAT score was 600. What must her grade point average be in order to be unconditionally accepted to the program? So that was a lot. And I think the trickiest part is how do we extract this first sentence and then rewrite that as an inequality, so that way we can solve for the GPA she must get in order to be accepted. So the first sentence is kind of confusing. So the part that you want to be able to pay attention to is we have an unconditional acceptance at the university will be given to students whose GMAT score plus 400 times the undergraduate GPA. Okay, So that's the condition, and then this condition has to be at least 1500. Okay, so if we were to write this out, rewrite that sentence, it says that so unconditional acceptance. Okay, so it's gonna be GMAT score plus 400 times the GPA. Okay, and then that result has to be at least 1500. So at least, this is at least greater than or equal to 1500 at least. Okay, so now we're saying that, hey, Robin's GMAT score was 600. Okay, so that's Robin's score, 600. Okay, plus 400 times. We don't know what her GPA is, so let's call that X. And we want this to be at least 1500, so now we can backtrack and solve for X. Okay, so we have 600 plus 400x greater equal to 1500. Solve 600, subtract 600 both sides, so we get 900. Divide by 400 both sides, so 9/4. So x is at least 2.25. So we're saying that Robin's undergrad GPA must be at least 2.25 in order to be conditionally accepted, okay, into the program.